So hi, I'm actually going to speak English if that's okay, because it's recorded and I want to share it afterwards with some people. We're about the sub-headline here, Troubleshoot Smarter. So Mavenode is a smart troubleshooting system that helps, for example, a technician do two things. So one is to find the root cause of a problem with a machine, like why did it break, why is it not working the way it's supposed to. And the second thing is to actually correct that problem, to fix it in an iterative way. So you change something and the machine says something, responds to you in a certain way, you change something else, and it's kind of a creative thing to make that machine work again. So it's basically AI for fast, accurate repair. And we do this by combining human and machine in a way that's a little bit different from how other people think about this problem. So we combine human and machine at least 3 different levels. So one level is human knowledge, like human experience of people who know how to fix these things, with machine learning, the data you collect and data that the machines give you. And the other thing is human judgment, actually like common sense and knowing that, oh, this doesn't seem reasonable even though this is what the machine says that I'm going to do. Combining that judgment with objective probabilities and actually have some kind of metrics and an objective way to think about this. And the third way we do it is combine actually human observations, like your eyes and ears, and you can smell stuff, with sensor data from the machines. So it's always this thinking about how do we combine human and machine rather than just having a black box that spits out a recommendation to the humans. And it's really kind of more broad than just what I just said. We think of this as a maintenance infrastructure. So there's 3 different aspects to that. So one is, how do we take all the knowledge in an organization about how to fix things that break and then put it into one place under one model? The other thing is, how can we make this model human-friendly, human-centric, so that it reflects the way people actually think when they're fixing things? But not just human-centric in that sense, but also how can we make it modular, flexible? How can we think of the knowledge that we store as Lego blocks where we can mix and match them? How can it be easy to interpret so people know, what do we actually know? How can you answer that question? If you just have a black box or a neural network, you actually don't know what you know, always. And the final thing is that it's very important that our platform is open, has been one of the guiding principles. So all the data, you can get it in and out however you want. A lot of industry people use decision trees still. So it's very important that we can convert back and forward between these things. It's open API, open architecture. So we worked with some of the largest Nordics companies. We started actually as a research project at 6 Swedish ICT, and we worked with the top 3 ones here. Then we added, the commercial aspects has gone fairly well. And I want to share with you the kind of dirty secret why we have been able to sign up so many large companies where there's this asymmetry, right? We're a small startup, they're huge companies, they're slow moving, we're fast moving. And the dirty secret is that we actually build a troubleshooting system for them as part of the first few phone calls. So we literally just ask them to send over a troubleshooting manual, they send it over, we talk to one expert, then we build a troubleshooting system that we then demo. And that has been very, very effective, and it's hard for other people with other approaches to follow. And it's everything from customer support, so people who are, you're calling, you're saying, oh, my machine just broke, it's, smoke is coming out of it. And the people who respond to that call, they need some kind of decision support to help you navigate that problem. What questions should I ask first? Okay, so the system says I'm going to ask this question, but maybe that's kind of stupid because I already know that's not a good question to ask. So giving those people the flexibility to get guidance, but not being forced down a script. Like when I call 1177 in Sweden, and I'm saying, oh, I have some health problem, you can tell that the person has a script or a decision tree, not a very good, not a good system. And it's all the way back to actual technicians, back in the R&D lab even, or at factories and so on. I want to show you 3 applications that we have. So application number 1 is Mavenode Troubleshooter. And this is basically a interactive question and answer system. But you can also see what data is coming from the machine, and then what questions is the system asking me as a human to answer. So as a human, you might get, this is a stupid example, compression level, but a better example is, is it smelling burnt right now? is this cord connected to this other cord? Is there a crack here somewhere? Things that you don't really have sensors for, it's very good to ask a human. But then they can switch between these two modes. And as you answer questions, you get probabilities of root causes on the right side, but you get them in real time. So getting them in real time means that you can kind of play around. You can change an answer to a question, see how that changes the probabilities. If you feel that, hey, I'm going to take an action now that's expensive for my organization. I'm actually going to change a component that costs $10,000. Before you do that, you might want to double check it. So then we have this kind of gamified way of thinking about that, where you can play around with different inputs and see if the output changes. And again, that's something we can do because the system is very fast. So as soon as you change something, it actually does change thousands of probabilities. It recomputes them in real time. And the other thing, just to point out this principle of combining human and machine, is that we rank these questions according to cost, right? So you can look at what's the time and what's the money cost of answering these, and also probabilities, of course. How much do we gain? So you can get a ranked set of questions, so you get some guidance, but also we don't force you down a path. So you can scroll through these questions if you want. You can search for questions and just answer those. You can search for keywords. You can click here on components and zoom in on a subpart of the system. So you could say, here's my big truck, it broke, assume that there's something wrong with the engine, and only give me questions assuming that the engine actually is the problem. And then the system will try to find, it's the battery or whatever it may be. Actually, the battery would be electrical system, I guess, but I mean the engine area. Okay, so finally, the machine learning component here comes in from asking the person, did this solve the problem? And we can ask different kind of questions, but the typical one would be, did this solve the problem? Was this the right root cause? And finally, this gets saved, and then once this case gets saved, that one is combined with human knowledge in a flexible way. So we have both real cases from real machines that broke, combined with prototypical examples of how people say that the machines should break, the theoretical part. And combining these two in a continuous way, so you always combine human and machine. That's very valuable because if you go to an organization, usually the story I hear is, we have these 5 machines are connected, we have this connectivity project, but all these other 950 machines, they're not connected. So it's a key lesson that we learned is whatever solution we have, it has to work from day one for both machines that have no data at all and machines that are like hardcore IoT. So you need to have a solution that works for both and kind of degrades gracefully to both use cases. We have Mayonode Builder, lets you build these models in a very simple way. I actually did this yesterday for a company. I did it myself, just home at 8 p.m. And it took like 30 minutes. They had like a web shop, and this is like very specific use case where people call in, they have a problem with their web shop, and they had this fault tree. So we just converted it very quickly, built a model here, and then we had something that immediately was better than a decision tree at least. So you can kind of act quite quickly rather than spending 2 months in building these systems. And then we help you visualize the diagnostic data, which is something that a lot of people don't think about. And of course, you don't want to replace existing analytic tools, like there's lots of good companies out there, Tableau and so on. So our approach is we want to show you and kind of let you explore the diagnostic data that helps you build these models. So in our case, people would just jump back and forth between this that we call Explorer and the other app, which we call Builder. So they explore, they see, this fault has trended up in time, or this fault is very, very common in our organization. So then we need to maybe look at the model for how we represent that fault. So it guides you even how to build the model. And finally, management also has to have some nice numbers and metrics and so on. So we make that very easy. And we kind of opted for simplicity here. So people actually can define their own metrics, and we compute them, and then we display them. If you want a demo of this, I'm happy to show it to you. You just go to mavenoid.com. There's some links there. Or you can ask me today, and I can show you. I brought my laptop, so I can show you a demo as well. I'll jump through this one. Just a final point here to make is that the bottom row here says 2 things, right? So one is quick to build train. This is our secret weapon, our secret sword that we use when we are talking to companies. And the other one is that it's easy to update our system. None of these things are really true for any other method that I'm aware of if you don't modify them, right? So if you do a Bayesian network or neural network, I don't know how many of you are familiar with these different technologies, but basically at a high level, you can have data-driven methods, right? Where you only based on data, and you build a model, and you have a black box, and then you get input to the black box, and then the black box sends you output. When that's the case and the world changes, you need new training data to update the model. And often that data is not available, especially for large, expensive machines. So our approach is kind of to, when you don't have data and when you actually don't know, then you're able to kind of, as a surgeon, inject human knowledge into the system. So the human knowledge can kind of bridge the gap whenever you don't have data. That's the basic idea. Okay, so last slide. I just wanted to share with you our kind of 4 pillars, which these things are a little bit abstract, and you have some kind of philosophy and so on, but they're actually very helpful to guide our decisions when we build product, how we engage with customers. And the main one that I've talked about today is number 1, which is our kind of, how do we amplify human troubleshooters instead of asking the question, how do we replace them? This is kind of the main thing. And quickly, the other pillars are, we want to democratize diagnosis, number 2. So we want to make everyone, like whenever you see a problem, you should be able to pull Mavenode up on your phone and actually start putting in some information to that problem, or escalate it, but you should at least be able to, everyone should have a shot at solving problems when they see them. And we don't think there's a contradiction between being fast and being right. You can be very, very accurate, but also super, super fast if you combine human and machine, because we are good at different things, and sometimes a human can kind of radically short circuit or make the search space smaller, whereas a machine can't always do that because they don't have common sense. And finally, we have this notion of lean troubleshooting, which is, we build a version 1 in half an hour, 1 hour, actually something that's like not unreasonable at least, and then we iterate on that. So it's not, we go away for 5 months and we look at all the data, analyze it, and then here you have your system. But we build it iteratively with the organization, starting with no data or with very little data, and then kind of making the system better as we go along. Thank you.
Thank you, Shahan. I think one of the great things I really love about Mavenode is that you don't actually count out the humans.
Yeah,
this is like, okay, we still need it.
There's still hope. Yeah.
There's still hope.